Well, welcome back from spring break, and I hope you're all doing well. We're going to work on probability section 2 today. I'm just going to go over these notes real quick with you, and then I want you to give the problems on where it says the page that says homework assignment on it. Give those problems a try, and then we can talk about them in our Zoom meetup. Okay, so we're going to talk about independent events today. So independent events are events that do not have any influence over one another. So events that don't have any influence over one another are if my cat barfed today and you did your homework. Those two events would have no influence because you don't know my cat. And that wouldn't affect whether or not you did your work anyway. So that's just a silly example. But an example that is often used are like flipping a coin and rolling a die. The coin and the die cannot talk to each other, so they're considered independent. So we say events A and B are independent. Then the probability of A happening and B happening is equal to the probability of A times the probability of B. So then it says, see example 1. So if we flip over to example 1, example 1 gives you multiple choice. So there's a multiple choice problem. Suppose you roll a red number cube and a blue number cube. Now the cubes cannot talk to each other, right? What is the probability that you will roll a 3 on the red cube and an even number on the blue cube? So they're not going to influence each other. So you can go ahead and say that the probability of a 3 on the red times the probability of an even on the blue. So the 3 on the red cube, you have a 1 in 6 chance of getting a 3 on the red. And even for the blue, you have 3 out of 6 for even. These are regular dice, by the way. They have 1, 2, 3, 4, 5, 6 on the pips on the dice. Did you know that the little dots on dice are called pips? Just saying. The number of pips is 1, 2, 3, 4, 5, 6. So there is 1 3 out of the 6, and then 3 of the 6 are even. 3 out of the 6 are even. So there you go. You do a little multiplication. Always reduce your fraction because this is not a number. This is a ratio. 1 out of 12. All right. So we're not going to measure 1/12. We actually have a ratio. It's a relationship of success to total. All right. Next, selecting with replacement. So let's say if you've ever played Scrabble or Bananagrams, you take an item chosen, an item is chosen from the bag, and then if it's something that you don't want, you put it back into the bag. I don't know if that's really a rule to Bananagrams or Scrabble, but imagine yourself pulling out your letters and you're like, yeah, I don't like the Z and I don't like the J. Put them back in the population. So let's look at example 2. Example 2 says, in a word game, you choose a tile at random from a bag containing the letter tiles shown, which BT dubs, the letter tiles are over here. You replace the first tile in the bag and then choose again. What is the probability that you will choose an A and then an E? So you need to look at the letter tiles. We're looking at the probability of an A times the probability of an E, because if you put it back in the bag, you still have the same number of tiles you started with. So let's look at all of these tiles. In the bag, we have how many A's? 1, 2, 3, 4 A's, and it says, does it say how many tiles there are in the bag? It doesn't, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 tiles in the bag. So 4 out of the 15 are A's. You put the tile that you got, the A, back. Now let's see, how many are E's? 1, 2, 3 out of the 15. 3 out of the 15 are E's. You still have 15 in the bag, right? Because you put the first one back in. So you've got 4 out of 15 times 3 out of 15. Multiplication and then reduce. So that's with replacement. All right, you give this one a try. Find the probability that you will choose at random a U and then an I after replacing the first tile. You can do it. I'll give you a second. choose a U, count up the number of U's. Then you choose an I, count up the number of I's. All right, so you should have 2 out of 15 were U's and 2 out of 15 were I's. So 2/15 times 2/15 is 4 225ths. Reduced. All right, now let's talk about selecting without replacement. So now this time you select the letter, but you don't put it back. So this is more, in my mind, this is more Scrabble-like because I think you have to keep the letters that you picked. It's been a long time since I've played Scrabble. There's a story here, but I don't have time right now. We'll talk about it later. All right, so here we go. Let's look at example 3. Oh, let me cover it up. Don't look, don't peek. I know you have it on yours, but whatever. All right, here we go. Suppose you choose a tile at random from the letter tiles shown. Without replacing the tile, you select a second tile. So what is the probability you will choose an A and then an E? So it's very similar to this one up here, except we're not replacing. So, oh, do you see the bug? There's a bug on the paper. That's kind of exciting. Oh, he left. Shoot. That was kind of fun. Okay, so choosing an A and then an E without replacing it. So the probability of an A, well, first of all the letters are in the bag to start with. So if we choose an A, it's still 4 out of 15. All right, you're going to keep that A. You're going to keep the A. So now what's the probability of choosing an E? Well, there are 3 E's in the bag, but how many letters are there altogether? You already pulled out 1, so there's now 14 in the bag. So 3 out of 14. That's why it says the population size decreases. So, and then it's got my little teeny tiny handwriting, but you can probably figure it out. 12 out of 210 equals 6 out of 105, which is equal to 2 out of 35 after you multiply. Okay, now you do the quick check. Ready? Quick check 3. Find the probability that you would choose a U and then an O without replacing the first tile. So a U, probability of a U, then the probability of an O without replacing. Probability of a U, 2 out of 15, 2 U's out of the 15. Don't put the U back. Now there's 4 O's, but there are 14 tiles left in the bag. And when you multiply, you get 4 out of 105. Can you cross cancel when you multiply fractions? Absolutely, yes. Absolutely. All right. All right, so now let's do this last example. Suppose a teacher must select 2 high school students to represent their school at a conference. The teacher randomly picks from a hat that contains the names of 3 freshmen, 2 sophomores, 4 juniors, and 4 seniors. That's a small school. What is the probability that a sophomore and then a freshman are chosen? Okay, so here we go. What is the probability of a sophomore? How many students are there? There's 3, 5, 9, 13 students altogether. So there's 13 altogether. And how many of them are sophomores? 2. Are they going to put the sophomore back in the bag, so to speak? Does that make sense to put the sophomore back into the pool? No, because the sophomore's been chosen. It doesn't make sense to be chosen twice. So the sophomore is going to sit out. Now what's the probability of choosing a freshman? Well, there are 3 freshmen. How many students are there to choose from? There's 12 to choose from. And then we can do a little cross-canceling if you want. So that'll give us 1 out of 26. All right. What is the probability that the teacher chooses a sophomore and then a junior? Okay, I'm going to let you take a second to work on that. I'm going to let my cat in. Work. Why are you out in the rain? It makes no sense. Okay, so choosing a sophomore. How many sophomores? 2 out of, there are 13 students, times a junior, there's 4 juniors and then 12 students to pick in the bag, so to speak. All right, and so we've got 2 out of 39 when we reduce. All right, and then what is the probability that the teacher chooses a junior and then a sophomore? So this is interesting. We're changing the order. Let's see if order matters in this situation. First, you choose a junior, which is 4 out of 13 times a sophomore. There's 2 sophomores out of 12. Now, what property do you know to be true about multiplication that will help us work smarter, not harder here? If you said commutative, you are right. The order that you multiply the numerator and the denominator doesn't matter. You're still going to get the 2 out of 39. All right. Give that work a shot, and I will see you at our Zoom meetup, and you can ask me all kinds of math-related questions that you would like, either from this assignment or the one from before break. And then the solutions are on the last. Don't do the stuff that's crossed off, right? The solutions are on the last page. All right? See you in a bit.